Hi guys, welcome to another session of General Chemistry 2. For our next session, we will now cover this most essential learning competency, which is describe and differentiate the types of intermolecular forces or IMF. What are the unpacked learning objectives? Number one, for you to be able to define intermolecular forces. Second, for you to describe the different types of intermolecular forces, and lastly, for you to compare and contrast the different types of intermolecular forces found between molecules. So let's begin by defining intermolecular forces. So strictly speaking, we should compare it with intramolecular forces for clarity. So let's begin. Intermolecular forces are the forces that hold molecules in a substance, while intramolecular forces are the forces that hold atoms in a molecule. Next, intermolecular forces are weaker than intramolecular forces, while intramolecular forces are stronger than intermolecular forces. Next, for intermolecular forces, they determine the state of matter, solid, liquid, and gas, and their physical properties such as melting and boiling point. While for the intramolecular forces, they determine chemical behavior of a substance. For the intermolecular forces, these are just attractive forces between molecules. While for the intramolecular forces, we are referring to the chemical bonds, which can be ionic, covalent, or metallic bonds. Next, for the intermolecular forces, they can be categorized into dipole-dipole forces, London dispersion or van der Waals forces, and hydrogen bonding forces. While for intramolecular forces, they can be categorized into covalent, ionic, and metallic bonds. Now let's look on the two pictures here. So we have two sets of molecules here. The first one on the upper part, the white picture or the picture with the white background. We can see here that we have 5 molecules of water. So if we can identify the intermolecular forces, it exists between the 5 molecules of water. While for the intramolecular forces, it exists within the molecule, or it exists within the bond between hydrogen and oxygen and another hydrogen and oxygen bond to form a complete water molecule. So that's when we refer to it as intramolecular forces. And from the definition again, intramolecular forces are stronger than intermolecular forces. So looking on the other picture below the water molecules, we have 1, 2, and 3 hydrochloric acid molecules. So for each molecule of hydrochloric acid, since hydrogen has lower electronegativity than chlorine, they tend to have what we call dipole moments. Just like in batteries, they have the positive pole and the negative pole. So using the Greek letter sigma. So for each hydrochloric acid molecule, you have their dipole moments, which is made up of one positive pole and the other one is a negative pole. And between them, between at least two hydrochloric acid is your intermolecular forces of attraction, while between the hydrogen and chlorine, you refer to this as intramolecular attraction. So let's now describe the different types of intermolecular forces or IMF. For the first picture here, we have 1, 2, 3, 4, 5, 6, 6 types of IMF pertaining to ion dipole, hydrogen bond, dipole, dipole, ion induced dipole, dipole induced dipole, and dispersion forces or London forces. So what is the description, or where can you find the ion dipole? So based on the picture here, it usually is found as an intermolecular force between an ion and a dipole, or a molecule with a dipole charge. So in terms of the strength, measured in kilojoules per mole, it takes about 40 to 600 kilojoules per mole to separate ion or to separate molecules having ion dipole forces. An example would be a sodium ion, which is near a water molecule. So they form an ion dipole. Well, for example, for the hydrogen bond, it's a polar bond that exists between hydrogen, or the hydrogen dipole charge, because of the high electronegativity of nitrogen, oxygen, and fluorine. So in terms of strength, it usually needs 10 to 40 kilojoules per mole of energy to separate molecules with hydrogen bonding. So hydrogen bonds, for example, exist between water molecules. But it can also happen between water molecules and a molecule containing uh, an atom with high electronegativity like nitrogen and fluorine. Next, we have the dipole-dipole. So earlier, we have shown you the picture of chlorine, I mean hydrochloric acid, wherein hydrogen is bonded with chlorine to make a covalent bond. So that's for the intramolecular. In terms of the forces between those kind of molecules, for example, we have here between iodine and chlorine. They are both electronegative, but they have different electronegativities. For example, chlorine has higher electronegativity than iodine. So for the temporary negative dipole exists in or exists near the chlorine atom, while the temporary dipole or the temporary positive pole exists in iodine. We should all remember, just like in magnets, like charges repel while unlike charges are attracted. That's why chlorine, being highly negative, is attracted to the dipole of iodine, which is in the temporary positive state or positive dipole. That's why they form dipole-dipole forces or intermolecular force. So it takes about 5 to 25 kilojoules per mole to separate molecules with dipole-dipole forces. Next is an ion-induced dipole. It usually exists between molecules with a polarizable electron cloud and an ion or an ion with a charge. Remember, we have two types of ion. It can be positive ions or the cations, or the negative ions or anions. It takes about 3 to 15 kilojoules per mole to separate molecules with ion-induced dipole. What are the examples? For example, there we have an ion here in the form of iron with a charge of positive 2. So if it encounters an oxygen which is highly polarizable, they form ion-induced dipole. So the ion here will affect the oxygen atom. So the oxygen atom will form a temporary dipole or a temporary negative dipole. So just like the battery, we will form a positive pole in the side of iron and a negative pole on the side of oxygen. Now, another type of induced dipole is the dipole-induced dipole. In this type, a dipole, for example, the hydrochloric acid, will induce the formation of another dipole in a polarizable cloud like chlorine or Cl2, which they exist as diatomic. So if you put the HCl near a chlorine atom, they form, or the HCl induces the formation of a temporary dipole in the chlorine atom, right? So one side of chlorine would be positively charged, and the other side, the other chlorine atom would be having a negative charge, or it would be an what we call an induced or temporary dipole moment. Next, going back there, we need at least 2 kilojoules per mole until up to 10 kilojoules per mole of energy to separate molecules with dipole-induced dipole forces. So lastly, we have our dispersion or London forces. All types of molecules have this type of force because most of the molecules have polarizable electron clouds. So when you say polarizable here, they have the potential to form dipoles or the ability to form dipole moments pertaining to, for example, having temporary positive and negative poles. It takes about 0.05 up until 40 kilojoules per mole of energy to separate molecules with dispersion forces. So an example here will be two sets of fluorine. So they are diatomic in nature. When you put them side by side, so an F2 molecule and another F2 molecule, they will have what we call dispersion forces. But all molecules have this type of intermolecular force, the London forces or dispersion forces. So in terms of strength, we have arranged this according to, in terms of the strength of those intermolecular forces, we can arrange them as number 1, iron dipole as the strongest, followed by hydrogen bond, followed by dipole forces, followed by ion-induced dipole, followed by dipole-induced dipole, and lastly, the the weakest intermolecular force, or what we call dispersion or London forces. So let's now have the last learning objective, which is for you to be able to compare and contrast different types of intermolecular forces found between molecules. So you just have to be familiar with the following descriptions of the different IMFs or intermolecular forces. So for the ion-ion interaction, or these are the strongest type of intermolecular forces. The nature of attraction is the attraction of a positively and negatively charged ions. These are very strong. Types of functional groups involved will be molecules with charges such as the ionic species. And usually they usually form the ionic bond. Next is the ion dipole. Interaction of a molecule with a charge and a molecule with the dipole. This is strong. An example is the interaction of water that has a strong temporary dipole with positive and negative ions like sodium and bromine. Next is the hydrogen bond, medium strength. This is a special type of dipole-dipole interaction between an acidic hydrogen and a lone pair. So if you can remember, if the lone pair exists in atoms with a free pair of oxygen, yung two dots na nakikita sa bonding or sa lowest electron, which we will discuss if we review that particular session. Next is the dipole-dipole moment or the dipole-dipole interaction. It's a weak intermolecular force. It is a molecular dipole. It exists between molecules that generate partial charges or sigma or a positive pole and negative poles. It exists between organic molecules like ketones, esters, alkyl halides, any molecule with a dipole or a strongly polarized bond. They form dipole-dipole interaction. And lastly, for the dispersion forces, these are very weak interaction. Attraction of weak random dipoles formed on a molecular surface. In terms of the organic molecules, they all exist in alkanes, alkenes, and benzenes. The larger the surface area, the better. Shape and size matters. Every molecule can form this, but they are weak. So if there are other interactions, those interactions will be dominant. So as was said earlier, London forces or the dispersion forces exist in all molecules, but they are very weak. That's why they can be dominated by other types of intermolecular forces. But to emphasize here, ion-ion is not an intermolecular force since it can be considered as an intramolecular force. That's why it is described as very strong. If you can remember, intramolecular force like ionic bonds here, ito yung tinatawag na ion-ion interaction, are stronger than all the IMFs or the intermolecular forces. Okay? Let's now have a simpler version of the comparison and strength or the comparison of strength of IMFs or intermolecular forces. So look at the picture here. In terms of the intensity of the color red, it signifies the strength of the IMF. So dispersion is the weakest, followed by dipole-dipole, hydrogen bonding. The strongest would be the ion dipole. The dispersion forces exist between all molecules and atoms, while dipole-dipole exists between only polar molecules like water and alcohol. Hydrogen bonding, molecules containing hydrogen bonded to fluorine, oxygen, or nitrogen. So you should remember that description. The ion dipole is a mixture of ionic compounds and polar compounds. So when you mix water molecules and salt, they will form the ion dipole intermolecular forces. So let's now have your activity 3 for intermolecular forces. Same directions. Number 1, identify the IMFs found in the following set of molecules. A. Water molecules. B. Water molecules near fluorine. C. Hydrochloric acid molecule near iodine. Let's arrange the given set of molecules in number 1 in terms of increasing intermolecular forces. And lastly, for number 3, is there a relationship between the type of IMFs between molecules and their boiling point? Why or why not? So that's it for our third session. Thank you and have a good day.